Okay, here we go. Hi, hello everybody. Welcome. I'm very excited to have Chris on our on the Sunday podcast stream. What can I say about Chris? I think everybody knows. You most likely know him better than you do to me, but let me try to do a short introduction, right? So, we know Chris primarily from he's an active member on Twitter, on Slack. He answers a lot of questions. I'm pretty sure he has notifications for anything Lens. I'm pretty sure he has a ton of notifications for for every Lens word possible because he seems to always be there and answer them. He wrote the excellent Objects by Example book. He's been playing with like a few of Haskell optimization things, Comonads, and a lot of cool things. So I guess without further ado, let's introduce Chris. Give me one tiny second. Let me swap scenes and where is it? There we go. Hey, hello, Chris.
Hey, good to see you.
Hey.
Happy to be here.
Yeah, I'm very happy. Oh, I did not transition to this. Okay, there we go. And now everybody can see Chris, not only myself.
Okay.
Cool.
Technology is broken.
Yeah, it's very hard. Computers are hard. Okay, so cool. So let's get started. Oh, by the way, please let us know in chat if the volumes are off, if I'm too loud or Chris is too loud or anything like that. Please let me know, and I can definitely fix that. Okay, so yeah. Hey, welcome. How are you, Chris, today? How are you today?
It's actually a beautiful day here. It's we're in full fall mode, so all the trees are turning yellow, and it's a little bit warmer. It gets pretty cold. We usually get snow at some point in October here, so
Okay.
no snow yet, so that's 2 thumbs up for me.
Okay,
happy.
cool.
Mm-hmm. And how are you? How are you doing?
I'm great, actually. I'm very excited about this stream. Actually, this is I'm not gonna say the last, but at least for a little while will be my last stream at this hour. I'm switching to an earlier hour, so we'll see how that works. And that's why I wanted to have you on, because we've talked about having you on one of my streams. But then if it will be like 6-7 hours earlier, that's probably a bit rougher for you, right?
Yeah, maybe a little. I appreciate you spotting me in before the change.
Absolutely, my pleasure. Okay, cool. So I guess let's get started, right? So this is one of the questions I always think to ask people, but I always forget. So let you be the first one who gets this question, right? So can you tell us a bit more about who Chris Penner is, like? And of course, only share what you're comfortable sharing. But what?
Sure. What do I like to do? Well, I'm a programmer, obviously. I do Haskell mostly in my spare time, just kind of as a fun thing. I mostly write Golang and Angular at work. Aside from that, I am a huge acro yoga fan, so I do a lot of that. If you haven't ever heard of it, I'd suggest Googling it. It's kind of like a partner acrobatics thing that's has some roots in yoga and some roots in acrobatics. A lot of fun.
Cool.
Some people might know me from, I used to make music on old 1989 Nintendo Game Boys. So I made chip tunes, chip music, that sort of thing. So I've licensed out a fair amount of music from that. I actually have licensed out a song to Pokemon, so that was kind of a fun little project.
Awesome.
Lots of little things like that. And during quarantine, I've mostly been doing handstands, to be honest. That's what I do in my spare time. So it's very addicting.
Cool. That's very cool. Okay. So then let's get to the question that I actually ask everybody, right? Which is because again, we're in a pretty small community, right, with FP, right, and compared to most the popular language, like JavaScript to C#, Java, and Python, and so on, right? So the interesting is how did you get into FP, right? How did you learn about it? Why was it interesting to you, and so on?
Yeah, the whole reason I got into it was almost literally because I was just bored at university. So I got into my my 4th year of my computer science degree, and I had already been working over the summers for the past 2 years for my company that I'm at now, and So I was pretty comfortable with most of the assignments, like the little Java kind of assignments that they give you. So I was looking for something a little bit more interesting, and I'd taken just the bare minimum of Haskell in a previous class the year before. But we didn't get into anything interesting. We didn't get into laziness. We didn't get into type classes. It was
Mm-hmm.
really just like, oh, this is how you like add two numbers together, right?
Okay.
Um, but I'd heard a lot when I was digging into that from people who were like, oh, yeah, I learned Haskell. It changed my life. It changed the way I think about programming forever, for better or worse. And it was just like a really impactful thing for them. So I was like, oh, well, I've got some spare time. I really like programming. Let's dive into Haskell and see what happens. So I picked up the the Haskell book and Haskell from First Principles, and I spent most of that year just kind of digging through that book. And ended up taking on as my first project and decided to write a text editor. I'm a big Vim nerd, so I was like, oh, let's see if I can like write a Vim in Haskell. And the reason I picked that is because I knew that it was like kind of one of those stereotypical things that are difficult for Haskell to
Mm-hmm.
do. It's got a UI, it's
Yeah.
got it's got an interface, right? It's got to deal with events and
And
data
states and a
processing and
lot
all of
of
this
yeah,
stuff.
yeah.
Yeah, exactly. It just has to do all of the things that you don't really learn in your first Haskell class or whatever. Um, so yeah, that was a great experience. I learned a lot and got really interested in it, and from that point on, honestly, I just kind of got addicted. I think to the idea of I really like elegance. Um, I just like things to make sense. I like things to like have patterns. And so if you look at a lot of the ways that you get things done in object-oriented languages, most things are just kind of big hacks.
Mm-hmm.
Like most
Yeah.
of the work you do on a day-to-day basis is just like, okay, like we have kind of even the Gang of Four book of programming patterns.
Mm-hmm.
A lot of those are just kind of like, well, this is a thing we often do because it makes things more sensible. But when I got to Haskell, it was like, oh, this is based on actual math. There are rules for this, there are laws, and that definitely appealed to my sense of elegance. So I don't know. The rest is history. Community's small. Everybody's great. Made a lot of friends here, and feel really comfortable. So
Okay, cool. So another Haskell who learned through the Haskell book, the tome, right? The like.
yeah.
So what was your process as you were like going through the aforementioned
Mm.
tome, right? Did you like do all the exercises bit by bit? Did you skip parts? Did you do extra projects in between, or did you just follow the book as a like a good soldier, step by step, and did everything as the book said?
I think I made it through maybe a quarter, maybe a third of the book to the point where I could, I had my feet underneath me and I could understand the language and kind of,
Mm-hmm.
I understood, oh, this language is different. This is how it works, right? So got to the point where I was comfortable looking things up and I could, do work on my own. And then at that point, I kind of switched over to working on the text editor like right away. I
Mm-hmm.
figure let's just jump in on a real project, and then I would consult the book back and forth for oh, how do I do this, how do I do that, and then a lot of Stack Overflow in there, a lot of just kind of banging my head against the wall trying to get things to work. I don't think I ever finished the book, maybe made it halfway through, but I got enough out of it to get moving, and that's what counts, I think.
Okay, interesting. You said Stack Overflow. My experience is that I very, very rarely find answers to Haskell questions on Stack Overflow, but maybe more beginners questions. Maybe that's true.
Well, so at this point, I dove in pretty deep, pretty fast. So my initial text editor approach, you can find it on my GitHub. I'll post
Mm-hmm.
a link to it in the chat here or whatever, maybe. But it was meant to be just kind of a fun experiment. I didn't expect to actually use it, and so I kind of went off the walls with abstraction and like coming up with plugins and those sorts of things. So my initial implementation, I think I started right off with like a type map so that people could store their own custom data as extensions in the state monad. So I like was using a state monad with a custom pipe map. And this is before Kawhi and other excellent pipe rep maps. I had to write that myself. And then I started using lenses to like index into all of these buffers and stuff. So I got pretty deep pretty quick. And so going on Stack Overflow, I would ask all sorts of weird, crazy questions. And anytime I learned something, I had to put it into the text editor. So of course the splits, the Vim splits and buffers are all of the transformations you do on those use recursion schemes, right? You have to. And then everything else is lenses. And then I built this weird multi-level, like you can zoom into the state monad and you can also unzoom back out. And so I built all these weird things, tried to find a spot to use continuations. It's very much a chaotically, I'd say it's designed by chaos. And I wouldn't recommend using it, but it was a lot of fun and it was a great first project.
Awesome. Okay, cool. So you kind of like dove right in and tried to figure things out from the get-go.
I've always found that to be the best way for me personally to learn. I like to set down a base framework and then add bits and pieces onto it.
Cool, because that sounds and a lot like my experience with learning Haskell. Because I also learned from the Haskell book, and but I skipped some chapters. I never finished it either. So right. But as soon as I was like midway through, I think maybe I learned about monads and kind of skimmed through like the monad transformers because those were very useful. I jumped right in halogen and wrote like a interpreter free thing with like halogen and PureScript, right? So actually no, it was actually for work, which is even more terrifying.
No kidding.
But no, we had to do a very, very small application that didn't really wasn't business critical. So okay, let's try out PureScript. Let's see how we can do. Let's something like that. And it was very interesting and learned a lot.
Yeah, and I think it's one of those things where as soon as you learn something, that's a hammer and everything else looks like a nail. So you try it out on all of these different things, and you end up with this just amalgamation of why do you have a free monad in there? And it's like, well, it kind of worked. And it's like, well, there's a better way. You eventually learn.
Oh yeah, well, also back then the only repository available with a complex halogen application was the Slam data one, and they used that. So I was like, okay, then that's how you do it, I guess. So I have to learn this thing, which probably was not required. Yeah, probably was not required for the thing I was building, but it was still I learned a lot regardless.
That's great.
Okay, so I guess so let's jump into Comonads then, because that's
Sure.
That's one of. So when was it? Was it like 2 years ago, or was it more than 2 years? Was it?
Okay, so this was Monadic Party of. I think that would have just been last year, actually.
Oh, really?
Not long ago. That's. Yeah,
I was thinking.
It would have been.
I was thinking,
June,
was it 2 or 3 years? And you're like, nope, just last year.
I think it was just last year. That's weird.
In my defense,
I don't think I missed one.
I guess in our defense, this has been a very long year, right?
Indeed. Yeah. What is it? March 217th. Yeah.
Yeah. Okay, so it was last year, March. Okay, cool. So you did this how should we call it? Seminar series on in Monadic Party, something like that, right? What was it? 3 or 4 part kind of introduction to Comonads, right?
Yeah. So I spoke at Monadic Party that year. In Poland. Wonderful conference. Highly recommend it. Really sad that it ended up getting postponed this year, but I mean that's a good choice. Really excited to go back. So if you hear about Monadic Party in the future, definitely check it out. And it's a week-long Haskell summer school is how they kind of describe it. And so they have lots of different talks at all levels. They have beginner, intermediate, and advanced. And you can kind of sign up for a different number of slots. But I did a 4-part, so that's about 2 hours of instruction. Or was it 4 hours? I think it was.
I think it's more than 2. I'm pretty sure it's more than 2. I'm not sure if it's 4, but it's more than 2 for sure.
Okay. I think it was 4 1-hour blocks of Comonads. And so the story kind of behind how I ended up there, I had just taken a job in Berlin a couple months earlier, and was just kind of getting settled there. And I decided that a goal for the year was to speak at least one Haskell conference. So I, went looking around, and this one was, it was like an hour by train or whatever. It wasn't too far away. and I figured it would be a good choice. So I submitted 2 or 3 different talk ideas. On honestly, how did I pick them? I literally I think what I did was I went onto Hackage and I searched for Ed Comet and I got a list of his libraries and I said, okay, which of these have I never heard of before, or which of these like have I not seen enough blog posts on, or he's always got interesting stuff.
Oh yeah.
So
But
I
it's
went
a
through,
very
I opened
it's
his
a
tab.
cool intersection between interesting and unfortunately not very well documented, right? So there's a
Mm-hmm.
lot of, but also very complex, right? So it's a lot of room for something. That's a great idea, right? And any of Matt's libraries are a very good example of things that could use a like beginner's introduction tutorials or something
Mm-hmm.
like that.
Yeah, exactly. So I knew it would be interesting, and I knew it would be useful. It would be elegant, at least. Um, and I think of it kind of like doing a jigsaw puzzle with those sorts of things. Some people they like to sit down in the afternoon and do a nice jigsaw. I like to sit down in the afternoon and try and figure out what the heck these types can be used for. So I've done that a couple times. And yeah, the Comonads one was the one that the organizers ended up picking as something that they thought would be beneficial to the conference. So then I started learning Comonads. This is very much one of those conference-driven development or conference-driven education sort of things,
Hmm.
where you signed up for a talk, now you have to actually learn it. So,
Oh yeah, and that's also one of the best ways you learn, right? Because you have to, right? You have to learn, and you have to learn well enough that you can explain to other people. So
yeah.
okay, so so I already said that you've enjoyed the conference. The experience was I guess it was very nice. So how were they received? Like, did you get as many people to go to that, or was it like were there multiple things in parallel, or was it just one thing at the same time?
Yeah, so usually we have 3 tracks in
Okay,
parallel. They do the beginner, the intermediate, and advanced talk all
okay.
at once, the whole time. And so yeah, you are kind of competing. Not, I mean, it's not really competing, right? It's just whatever everybody is interested in.
Hmm.
And luckily, actually, yeah, pretty much the whole way through, it was packed full. We had people standing, I think, for the
Oh,
last couple
cool.
sessions. So that's a really nice sign as a speaker, I guess. I was pretty happy about that.
So I'm curious, did
Um,
this go into the intermediate or advanced track? I guess advanced, right?
this this was actually
Oh,
intermediate, yeah.
really?
Advanced was like implementing a simply typed lambda calculus using dependent types and like stuff like that. So this
Okay.
was this was considered. I it's so funny what we call intermediate and advanced in Haskell. We
Oh,
talked
yeah.
about this last time we streamed, right? But
Yeah.
yeah.
Okay.
So this was an intermediate one, and luckily for the first couple sessions, it overlapped with Ed's talks, so he was not able to sit in the back while I was trying to foolishly explain his library. But we ended up having some good talks about it after. So yeah.
Cool. Okay, so like, well, if you were to like, what was your takeaway after doing all of that, right? So, how do you think the presentation was received? How do you think about the library after having done that? And like, what can you tell us about this?
Yeah, so I think the talk was relatively well received. It has a good number of views, I think, on
Mm-hmm.
YouTube, and I think it is really one of it's one of only. I'm not really even aware of any other talks that go all the way from what is a comonad and then explain each of the main
Mm-hmm.
comonad transformer types. It's kind of like the MTL of comonads, right?
Mm-hmm.
So it's the comonads library. And yeah, it goes through each one. There's like kind of a video for each of the different types, and it covers each of the things that you can do with them. So I think it was really well received there, and I still see people posting links to those videos from time to time, so that's great. And they invited me back to do another talk this year, so apparently it went over relatively well. So hopefully I'll be able to go back in a future year when Attic Party is running again and give it another go. Yeah.
Okay.
Uh, as far as Comonads go, though, uh, what I have an interesting relationship with them. I think they're fascinating, and I really, really want more people to know about them. But it's really difficult to recommend because comonads are not in base, right? So the monad type class is in, kind of the standard library of
Mm-hmm.
Haskell.
Yeah.
Comonads are not. So what ends up happening is we have all of these things that are Comonads but don't have the proper instances, and so people don't integrate them into their libraries, or they'll write their own custom functions and they don't use the type class, right? So
Mm-hmm.
Comonads are really everywhere, but nobody really knows about them, and none of the machinery works with Comonads. So that's kind of where I'm at. Is I think they're super useful and very interesting, but they haven't gotten the love that they need to be able to kind of hit that saturation point.
Yeah, and the big
And
problem is if you don't have the base types as Comonads, then when you want to wrap some combination, some composition of them as a Comonad, then you're going to have a hard
mm-hmm,
time because you have to manually define the instances and write them. And actually,
yeah,
it's not as simple.
makes it much
Like
harder.
the instances for Comonads are a bit trickier than the ones for Monads, right? So it's not like
Yeah,
a trivial task to do. Yeah.
yeah. I think it's like I mean, some of the more complex monad ones are really tricky too, but
Mm-hmm.
they're a little bit tougher to get your head around, right? And you don't hear about them nearly as much because it's
Mm-hmm.
not like we have an IO comonad that everybody has to use all the time, right?
Oh
So
yeah.
um, yeah, so I'd like to see them get a little bit more love, and I think they would end up getting more usable as a result. So if more people supported them, and we could get a little bit more performance, I think, squeezed out of them too. Because a lot of the use cases you'd want to use them for, like image convolution and stuff like that, they're just not performant enough in their current form. So they need to level
Mm-hmm.
up a little bit before they can hit the mainstream.
Yeah, well, one would expect that if they get into base, they would probably get some love from the compiler as well to get some performance improvements. Yeah.
Mm-hmm. Yeah, I think there's a little bit of research that needs to happen there too. Yeah,
Okay.
but
Yeah.
everything can help. Yeah.
So Gil Christian said, funny enough, I had a harder time to follow some of the beginner talks than the advanced ones in Monadic Party. And then CMDV asked if they were recorded. And yeah, I think most of them are recorded, as Gil said. Okay.
Yeah, that's right. I have a playlist on my YouTube channel here. I'll just find that link real quick. Here we go.
Cool.
Let's copy. And we'll drop that in chat. There you go.
Cool. Thank you.
Yeah, if you're in for 4 hours of Comonads, go for it.
Okay, cool. So then I guess we can. Is there anything else we should be talking about in Comonads? Because I think that's like, I mean, that pretty much sums it up for me, right? It's that they're very interesting, and of course we're not going to be able to explain what Comonads are now, right? During this thing, right? We just like we're just mentioning. If you want to, you can watch the like 4-hour excellent introduction that Chris did there. But I think that definitely touches the main part, right? They're not in base, which means that like okay, if you want to use them, it's not hard to import the extra package. But then the problem is that again, the other packages don't have instances, and right? If it was in base, then probably more people would include the instances, right? I think that's the point you're making. So then you end up using like map instead of app map, right? Like specific functions that work for one type rather than the generic instance methods, right? And again, for like complex use cases, the performance might really bite you, and sometimes it's unexpected, like the complexity you get, because you just throw expands there and, and so on, but then you go, oops, wait, right? It grew, yeah, like the memory usage, the like allocations group can easily get out of control.
Yeah,
okay,
yeah, that's for sure.
Well, let's jump into the next topic then, because there's one more project of yours that I found very well. A lot of them I found very interesting, but the like word count project started sort of like whole wave, right? Where like people started doing a lot of implementations in their languages and trying to beat the performance wise, or and also some people were like trying to get like better, like cleaner code, easier to read, and so on, right? People seem to be very, very interested in this word count sort of idea, right? Beating the like again both performance but also code cleanness and so on. So like, how did you get the idea to do this in Haskell?
Well, I think this is another one of those cases of I realized that I didn't know something very well, so I decided to take on a project for it, right? So high performance Haskell is kind of, nefariously known for being pretty tricky and very different from quote unquote normal Haskell.
Hmm.
You need to do a lot of things differently and all of that. So I was like, okay, well, what's something that I can very easily like tell whether I'm succeeding and doesn't take a lot of setup, and I have other places, to compare to, so that I can say, okay, well, I know Haskell can be as performant as C, and this is a very simple project. Just to implement, count how many words are in a file. It's very easy for me to check if it's correct.
Hmm.
So this is a good way for me to, start from nothing and see if I can figure out how to make this performant.
Yeah, and you don't need to set up like 10 Docker machines and REST APIs and all of that jazz, database and all of that
Yeah.
jazz, right? It's just, hey, I have a file, I can count it with like the existing word count, and I'll just run
Mhm.
Haskell version. Yeah, that's actually pretty cool. Okay, so how was
Yeah.
the process of like working on this?
Well, so I leaned pretty heavily on Cunningham's law for this one. So what that is that basically, if you're wanting to learn something on the internet, the best way isn't to ask a question; it's rather to post a wrong answer and wait for people to correct you. So this went through many iterations. I'd try one thing, I'd go around and look at some blog posts, and I would try a different thing. Eventually, it ended up getting posted by someone to Hacker News,
Hmm.
and it made it to the first page of Hacker News, which, if you've ever had that happen to you, is simultaneously it's exciting, but it's also a little scary and chaotic. Um, so I got a lot of messages as a result of that, saying, "Oh, this is super disingenuous for these reasons," or you, you're doing something completely wrong in this area, or you're misinterpreting the original C code and all of this stuff. And some of it had merit and some of it didn't. But there's a lot of wading through that and learning. And even after I'd posted it, someone from the Haskell community who works on the Streamly library
Hmm.
came and they showed me like a 3-line snippet that like doubled the speed of the program, and I was like, oh, okay, like this is exciting. Like there's new updates to this, and then what I actually really enjoyed about the project
Hmm.
was not even necessarily just counting the words and figuring out faster ways to do it. It was looking at how we can use mathematic abstractions to make things faster.
Hmm.
So word count itself, if you're going to try and keep up with C, you're going to have a really, really tough time doing it by just counting one, word at a time. So lazy byte strings are very fast and they're very effective, but you're not going to be able to beat C. So
Hmm.
I thought, okay, what can a modern high-level language do that C would have a bit more of a tough time with?
Hmm.
And that's parallelism, right?
Hmm.
So we all have so many CPUs, and we don't know what to do with them all. So what would a modern version of word count look like? It actually uses all of your
Hmm.
CPUs, right? And disk access is getting extremely fast with SSDs, and certain SSDs can actually, work in parallel and access memory
Hmm.
um, in multiple spots at once. So I set about designing a parallel version of word count that, if you have a 10 gigabyte file, maybe you have 4 cores, it'll split it into 4 2.5 gigabyte chunks
Hmm.
and count all of the words in each of them, right? Um, and so Haskell is very good at parallelism, but also we can express this word count operation as a monoid. Um, and this is where the secret sauce comes in, because if you're trying to do this without using this mathematic abstraction, the C implementation and pretty much everyone else just implements this as a fold over
Hmm.
characters, right? So you take a character, you check, oh, is it like a word character or a space character? If it's a space character, you probably bump up the word count, and then
Hmm.
you go to the next one and you grab all the spaces and you throw them away, and then you start counting characters, etc.
Hmm.
So what happens if you're using a fold-based implementation and you split your file on a word? So now you get to the end of the first chunk and you're in the middle of a word. You need to know whether you're starting, with a word on the next
Hmm.
chunk or not. And then you run into other problems where, if it's a UTF-8 file, you might actually be in the middle of a code point, like in the middle of
Okay.
a Unicode code point, right? So now you're like starting the next file halfway through a character, and it causes all sorts of chaos. Well, it turns out if you're doing it with a fold, it's really difficult. You have to handle all of these edge cases, and it doesn't really affect your ability to do it, but it does make the code extremely messy.
Mm-hmm.
Whereas if you're able to encode the ability to count characters and build them up into counted words as a monoid, you don't need to care, right? It's associative. You can split things up as much as you want, and you know it's always just going to work. And so that made it extremely easy to just say, oh, yeah, split it into as many cores as you have, and then just merge them all back together. And so long as you test your monoid follows the laws, made it extremely easy and still perform it. So that was very cool.
And I guess that's one of the things that the C people might have had problem with, right? Hey, you're cheating, you're using multiple, like using parallelism, and the original one didn't, so of course you're going to be faster. But I guess, that wasn't the point. But yeah, I can see how people would mind that sort of thing, or at least comment on that.
Yeah, definitely, right? And it's like, well, of course you're going to be faster if you're doing it 4 times at once, but my counterpoint to that is, well, then why doesn't the C version do it 4 times at once, right? And I mean, the answer to that is because it's 20 years old and, it just wasn't necessary. And also, who needs to count words that quickly? But, it's not like I'm selling this or anything. This is just a fun experiment.
Sure.
And I've gotten pretty good feedback on it from people who are like, oh, I didn't actually even know that these optimization techniques existed. I didn't know how to profile them. I didn't know about strict data, So it's, I think, done well.
Oh yeah, there's a lot of tricks to doing high performance, not even high performance, but just performant Haskell, right? Which aren't even like, because again, like we've gone through this at different points in time, but like there's really no good Haskell intermediate book right now, or if there are, they're very, very few, right? And I think Matt's working on one, Matt Parsons, and I think that there's I think there's another one that's being, I think people are just like, I don't remember the author, but I think he's just starting on it, and I mean there's very, very few, right? There's quite a few beginners books by now already. I think that there's a few more than there were a couple of years ago when we started. But like, and then you don't get this thing, right? You don't have the, like, here's what you do to make things like strict data, for example, something that you probably always want in an application, in any application, right? Just enable laziness as when you need it, not by default. Whereas in libraries, you probably want it to be lazy by default, right? But in applications, you almost always want strict data. Very rarely you'll need something like that, right? Like inlining is also almost always right in application code. Probably in library. I'm not even sure if in library you should be doing that or not, right? It's give me one.
Let me get a spam bot.
Let me get it.
Yeah, it's quite interesting. Too, when you look at kind of the difference between a production library and a quote-unquote normal library, right? And, you go digging in there and you'll immediately see CPP pragmas, right? Supporting multiple versions of GHC and then conditionally inlining things. And then you'll see rewrite rules and all of those, right? And it's just really that next level that almost makes it look like a completely different language.
Oh, yeah, for sure.
Unfortunately. But,
yeah, and then there's also like the debugging techniques, which again are very, very, like, you need to kind of learn how to read core, and you need to like, and again, there's like, okay, you can build with stack profiling, but you don't always get the best results from that. So I've seen, like, I think I've seen Alexis King talk about this sort of thing, where I think at Hasura they kind of moved away from stack just because they had problems debugging code with stack, and they kind of went to Cabal and like manually creating what was it called, the like cost centers, right? And so on, right? So it seemed like but again, I'm very sad that she didn't end up writing a blog post, because her blog posts are amazing. So I hope that somebody takes the time and writes, or maybe like even have a book on this sort of thing, right? Performance Haskell, which it doesn't have to be like as like, it doesn't have to beat C, but at least, okay, what are the things that I need to do if I need to make things faster, right? It's something that's
I appreciate having multiple levels of content for pretty much everything, right? Some people just want to sit down and read an entertaining blog post about, with maybe a bit of a clickbaity title, how to beat C and let's see what we can do, and other people jump on that, right? And they really enjoy. You're right. Like, this one did spark a little bit of a movement of people, just writing fun code and showing off and doing a little bit of code golf. And I think that's always fun and interesting, which probably isn't going to happen when you release a book, right? If it's not accessible for free. And then there's also definitely a space for well thought out, well constructed, long form prose on this stuff to take you from start to finish.
Mm-hmm. Yeah, for sure. Okay then. So anything else you'd like to add about this little project, or like did we cover most of what you think is relevant?
Well, actually today, yesterday and today, I was looking into some of the Hacktoberfest stuff, just kind of for fun, see if there was anything that needed a hand that I could contribute to. And I noticed that Coinic had posted a bunch of Hacktoberfest for their type rep map, which I've used in some of my other streams and would have come in extremely handy for my text editor project. So I thought, oh, okay, this is like a good project. And so I was digging into that, and they have done some really, really good work on making that high performant, and they have some benchmarks on that. And so it's cool to see. We were doing some, it's like cached binary search trees that use high performance like primitive arrays and that sort of thing, which is an area that I hadn't even looked into during the word count thing. So it was completely new to me. And it just, I don't know, it just made me think it's really cool to see how actually easy it is to work with even like mutable algorithms in Haskell. I would still rather write these high performance tight loops in Haskell than I would in C, even though it's not, regular Haskell. So I think there's a bright future for Haskell there. It just, needs a little bit more education in that area, I think.
Yeah, definitely. Like, and all sorts of things, right? As you said, we need like blog posts, we need videos that are maybe not just two people figuring it out, or one person, right? Just working through, okay, how do I do this, right? But we probably also need something more formal, if you will, right?
Yeah, I think that'd be great.
Yeah. Okay, cool.